With cluttered or noisy line charts, analysis tasks become difficult, for example, selecting the most significant peaks in this data. To overcome this, we can turn to data smoothing. However, many methods are available, and while their results look similar, each preserves different properties of the data. We present a framework for measuring the effectiveness of smoothing techniques on 8 different low-level tasks, and our findings summarize the effectiveness of 12 different smoothing techniques.
Nowadays, technology is developed for a single audience, assuming that one size fits all. Nevertheless, we all have individual differences such as personality. Taking into account how personality affects preferences, we study whether it has an effect on hierarchy, evolution over time, and comparison contexts regarding information visualization. We leverage all personality variables from the 5-factor model and the locus of control with correlation and clustering approaches, showing promising results.
Atmospheric convection is one of the most important phenomena in meteorology. It is responsible for cloud formation and storms. Yet, the measurements of the convective processes are expensive and scarce. In IsoTrotter, we collaborate with a domain expert to build an empirical model of the atmospheric convection based on paragliding data. We design a novel visual parameter space analysis technique using isostructures in the parameter space to explain and validate the model.
We used data from today's United States to recreate 7 abolitionist data visualizations, which were originally presented by W.E.B. Du Bois in 1900. Comparing the modern and historical versions, we can see continued racial disparity in America's geography, economy, education, and justice systems. This view of the past alongside the present invites us to look at the historical context for modern-day abolitionist movements.
To generate a visual data story, one needs to learn a lot of techniques such as data analysis, visualization, and scripting. To lower the technique barrier, we introduce an intelligent system, Calliope, to generate visual data stories directly from an input spreadsheet in a fully automatic process. Using Calliope, a good visual data story is just a click away from us.
This paper explores the efficacy of using narratives as a medium of explaining the causality in causal networks. Now, towards this end, we provide you a glimpse of CauseWorks, a causality visualization system for generating narratives given a set of interventions and objectives for a causal model. And we further validate CauseWorks through interviews with experts. Please read our paper to know more. Thank you.
How to know if a graph is correctly drawn? Are all the aesthetic properties preserved? To answer these questions, we currently use quantitative methods that require graph structure and are computationally expensive. We propose a new method to directly compute these metrics from graph layout images using convolutional neural networks. Below are the results. To know more about our approach, please attend our talk.
Over hundreds of tools exist for visualizing genomics data, leaving the analysts with a large design space to analyze before finalizing the visualization. We present a data and task-based recommendation system. The recommendation system uses a sequential model to suggest appropriate visualizations to users. To learn more about our recommendation methodology and results, please visit our poster.
Determining the veracity of a factual claim made by public figures has become a common task for journalists. However, fact-checkers face critical challenges as they try to sweep through a long transcript to verify claims. We present ClaimVis, a visual analytics system that supports the journalists to identify and verify claims from a transcript.
We present on the design process of creating a visual learning analytics system called SEAT, Student Electronic Exit Ticket, that aims to support equity in science classroom by making instruction more culturally relevant to all students. Thank you.
Classroom participation data disaggregated by race and gender can enable teachers to reflect on their implicit biases and consciously enforce participatory equity in their classrooms. In this work, we explore a design space for representing classroom data to enable teachers to compare contributions across students and student groups, as well as compare participation rates of the different student groups with their demographic compositions.
Tableau helps you see the stories in your data. It's designed to help you be smarter, so you can make better decisions faster. Connect to the data you care about. Sort, highlight, drill down, or filter your data in seconds. Add calculations to extend your data. With Tableau, you can keep on asking questions in the data until you discover the root cause. Tableau, answer questions at the speed of thought. Tableau helps you see the stories in your data. It's designed to help you be smarter, so you can make better decisions faster. With Tableau, you can keep on asking questions in the data until you discover the root cause. Share your analysis securely. Your entire organization can access these interactive dashboards from any browser or mobile device to find their own answers. Tableau, answer questions at the speed of thought.
In our talk, we will introduce a didactic methodology for crafting interactive visualizations. This methodology uses a construction kit that describes a visualization using a set of building blocks. Our approach contains 3 successive steps that can assist students and anyone interested in crafting, ranking, and improving new visualization ideas.
We present 3 external labeling concepts that allow a user to browse through point sets without the need of zooming in and out. In the first method, labels are distributed on multiple pages. The next method arranges the labels in a single row that can be continuously slid along the bottom side of the map. In our third method, labels are distributed on stacks, which a user can independently browse through.
When NASA engineers plan a mission, they turn to space trajectory designers to chart a path that minimizes the need for popular mass. In this work, we applied a topological analysis of the circular restricted three-body problem to space trajectory design, and demonstrate the benefit of this approach to devise compelling solutions to realistic trajectory design problems.
We present an exploration into co-located collaborative immersive analytics in a prototype called Fiesta, the free-roaming immersive environment to support team-based analysis. The prototype allows groups of users to visualize and explore their data in a room-scale environment, which we used in an exploratory study involving 10 groups of 3 participants. We focus on the roles which 2D surfaces have, as well as how users leverage the 3D space during both the individual and collaborative work.
The make of continuous color maps. We present the CCC tool, a new web tool for the creation, editing and analyzing of application-specific color maps. For the precise definition of color maps, we developed a new color map specification. This new structure increases the editability by reducing the numbers of colors to a minimum.
Hello, welcome back to VIS 2020. It's my pleasure and honor to have the first ever industry keynote at the IEEE VIS conference. And I guess this virtual conference has been an opportunity to try new things, and I hope this will continue. Maureen Stone is here representing has been an opportunity to try new things, and I hope this will continue. Maureen Stone, and she's gonna give a keynote regarding Tableau and the influence on this conference. And I think that's something we should really look up to in terms of combining the research of our community into tools that really make impact into society.
Hello, I'm Maureen Stone, head of Tableau Research, and I am delighted to be giving this sponsor's talk. Tableau's mission is to help people see and understand data. We do this by basing our products on a deep understanding of how people analyze and understand. In other words, we use science. And most of all, we use the research and ideas from the IEEE VIS community. We have many people in the company who are part of this community, and Tableau has been a major supporter of the VIS conference since 2007. Tableau is based on research done at Stanford by Chris Stolte and Pat Hanrahan. The ideas in Polaris and its visual query language, VisQL, are the heart of Tableau's analytic product. The Polaris papers are receiving the 20-year Test of Time Award this conference, which shows their importance to VIS as well as to Tableau. Another key paper is Show Me by Jock McKinley, Pat Hanrahan, and Chris Stolte. Show Me helps make exploration easier and more automatic. It includes the Show Me options menu, automatic marks, and more. While published in 2007, the work was part of the very first product. Finally, I'll take credit for adding some research in color and perception to the mix, which was applied to the creation of the Tableau color palettes starting in 2004. Put these ideas together with some excellent product design and engineering, and you get what you see here. First, connect to a data source, and then begin to drag and drop. The data is on the left. Each pill is a column in the database. Drag the pill onto a shelf, and it automatically generates a query, then creates a graphical view of the data returned. Tableau as a product revolutionized business intelligence by letting a domain expert explore their own data. And it set an intellectual standard for a tool that was both easy to use and allowed deep exploration. Tableau today is fundamentally the same as Tableau 2004. More features, of course, on more platforms, and much, much more polished. But still the same drag and drop visualize experience. This is both impressive and a challenge. To meet this challenge, we have expanded our product line to support the larger process of visual analytics. This process is illustrated here in a diagram we call the cycle of analysis. This diagram grew from research done around knowledge crystallization by Stu Card and was brought to Tableau by Jock McKinley. VisQL automates the query map and view part of this cycle, making it easy for people to quickly explore and visualize their data. Sustaining this analytic flow is a fundamental principle for product design at Tableau. Now let's take a look at other parts of the cycle. Getting the right data is critical, for if you don't have the right data, it doesn't matter how good your visualization looks. We created Tableau Prep to make it easier for people to organize and shape their data. We are now adding improved search, recommendations, and a data catalog to help people find and organize their data and other analytic assets. To be actionable, analysis must be distilled and shared. For Tableau in the enterprise, there are many people who use the results of analysis done by someone else. Tableau server products support sharing these results, which are primarily workbooks and dashboards. We support servers private to the business and provide a shared online server in the cloud. Information on a server can be viewed and explored on screens of all sizes. Tableau Public is a free service that supports the Tableau community. It was first launched in 2010 and now hosts over 1 million visualizations. Last year, we were acquired by Salesforce, which offers a full suite of services to support business in the cloud. In addition, Salesforce is deeply invested in AI, which has the trademark Einstein. Einstein Analytics supports data visualization and analysis on Salesforce native data. An important feature is Einstein Discovery, shown in the pane on the right, which provides easy and automatic predictive modeling. Einstein Analytics is now part of the Tableau product line and was recently renamed to Tableau CRM. With this as background, let's move to Tableau Research. Tableau Research was started by Jock McKinley and Chris Stolte in 2012 to create new research results of value to Tableau. To broaden our skills and influence, we are also active members of our research and technology communities. I was one of the original 5 members back in 2012 and took over from Jock as head of Tableau Research not quite 3 years ago. Here are the people of Tableau Research today, a round dozen of us now that Arjun Srinivasan has joined us just this month. As you can see, many of us are very much engaged in the VIS community. In addition, we enjoy having visiting researchers to help expand our ideas. Lynn Bartram is with us now. Marty Hurst was with us last year. Our website, research.tableau.com, provides both information about our researchers and includes an archive of our publications. We also have a poster in the poster section that details our contributions to VIS this year. I obviously don't have the time in this talk to try and describe in any detail what all we're doing. Instead, I want to describe 2 big ideas that are inspiring us in hopes that they will also inspire others in the VIS community. The first big idea is responsible analytic assistance. Visualization is a powerful tool, but can easily introduce bias or overconfidence. What can we build into our systems to make their output easy to trust and verify? As this diagram illustrates, there are many opportunities along the visual analytics pipeline to introduce bias and errors, or simply create opportunities for misunderstanding. So, how can we best help you to trust your VIS? We believe that the most challenging errors are those that are not obvious. We define a visualization mirage as a result that looks correct, but may still produce invalid insights due to any of a number of hidden problems. We need to apply creativity and new methods to help people recognize and correct mirages. One approach is to drive the verification and testing from the view itself. For example, permuting the rendering order changes which clusters are prominent, but doesn't change the underlying meaning of the data. A difference image can be used to detect such a mirage. This approach can also be used to detect data problems hidden by aggregation. If the relative heights of the bars change radically when the data is repeatedly sampled, the insight that on average Y sells more than X may be a mirage. Possibly the biggest challenge is to avoid overwhelming the user. Rather than trying to surface every possible problem, we need to show only what might be useful to explore further and make it easy to dismiss or ignore things that don't matter, like linting in compilers or spell checking in documents. Another part of responsible analytic assistance is looking at building ethical practices for visualization, design, and use. This includes looking broadly at what populations we are helping or hurting with our charts. Our colleagues at Salesforce are working to establish ethical AI principles and practices across the company. This is a large and ambitious goal that will take a while to fully achieve. However, these principles can and should be applied to any process that is designed to help people make decisions based on data, including visualization. Many efforts to make AI more transparent involve teaching and explaining the underlying processes. However, these explanations may offer little more than the parameters and controls of the implemented model expressed in natural language. We need to create human-centered methods and practices which are more specifically designed for different tasks and for the people applying them. Instead of offering and explaining all possible controls, we need to thoughtfully discover and design exactly the controls the user needs. My second big idea is data conversations. Ideas from natural language can be applied to visual analysis, where humans and computers have analytic conversations about their data. Our 2016 system EVISA demonstrated a conversational interface for exploring a data viz and inspired the development of Tableau's natural language feature, Ask Data. These systems demonstrate how including semantics and pragmatics lets us go beyond simple question and answer to create an analytic conversation. However, there is much more to do. We need to explore better ways to determine intent and leverage context. We need to learn how the system should respond to vague modifiers like many, most, big. We're exploring using sentiment analysis to help people interpret vague intent modifiers. Chatbots offer different challenges and opportunities for data conversations. But there is more to data conversations than natural language support for analysis. As well as conversing with data, we are exploring the types of conversations people can have through and around data. What do we mean by this? So as mentioned earlier, many Tableau customers use our servers to share dashboards, and many of them treat these dashboards more or less like interactive reports. But we are discovering that these customers want to do much more. Together with user research, we are studying the work practices of these people. For example, we published a qualitative study at VIS 2018 specifically about dashboards and how they are used. People in this part of the cycle of analysis are moving to action via insights and artifacts created earlier in the cycle and often created by someone else. But these people often have knowledge and sometimes even data that isn't reflected in the dashboard. They want to do more to see and understand their data, including cross-checking the results. I believe we will ultimately define a new cycle of analysis to support these users and their data conversations. It will be similar, but critically different to the one we use for exploratory analytics. We invite you to join us in creating it. In conclusion, we help people see and understand data. While that is Tableau's mission, we believe it also captures the spirit of the research here at IEEE Viz. Thank you and have a good conference. Well, then I'd better unmute myself.
Okay, thank you very much, Maureen, for the great presentation. And there is a feedback.
Uh-oh, I've got it. Well, I don't know. I mean, it's coming from Zoom, right? Because I've got Zoom muted. I have everything.
No, there is feedback. So we have some questions from the audience. In particular, people appreciate the user responsible analytic, and maybe would like to hear.
Mine is muted. Mine is muted. So maybe it's Valerio.
Can we go now?
Yeah.
Okay. Well, thanks, Maureen, for the great keynote. It is a great start for the community to have this type of engagement. And thanks for Tableau for the support. There are questions from the community, at top of which appreciation for the use of responsible analytics. And we would like to hear more of your thoughts about how that can be used to communicate uncertainty and avoid overconfidence.
Well, I pointed to a paper on visualization mirages by Andrew McNutt and Michael Carell, which is one really good deep way to get into that. I think that paper went to Chi instead of to Viz, partly because of the timing. And what it's doing is trying to understand what errors matter, right? And so I think that if people are trying to use a Viz, trying to gain insights from it, simple uncertainty is a start, but that's still requiring them to think somewhat statistically. I think we need to think more process-wise. Sometimes it doesn't matter that there's uncertainty, sometimes it does. I hope that helps.
Yeah, one more question is more related to your particular field of research in color, and maybe a few thoughts about how your engagement really influenced the design of Tableau from that perspective.
Well, I think we did set a really good set of standards for what color should be like for a general tool. And the fact that many of the other general tools have carried off our color palettes, especially the categorical palettes, is one indication of that. But I think it also just reflects the importance to the founders and to Tableau of the visual quality and the cognitive and the ability to really get the very best insights. So, you know, it's been great for me as a research field. I love seeing the research that's been going on since then in these things. Danielle Zafer, Karen Schloss. And so, yeah.
Okay, I think we're out of time. We would love to have many, many more questions. Thanks again, Maureen, and thanks for Tableau for the continuing support to the conference, especially in this challenging time. And we'll move on with the rest of the program. Thanks again.
So let me just quickly say, I will try to monitor the chat, both the Tableau channel that came up with this, and there's another Tableau channel in Discourse, or just reach out to me directly with questions, folks. And thank you so much for the opportunity.
Thank you.
Okay, bye-bye.
As visualizations begin to use color, shape, line, and form in new ways, legends often go overlooked as essential to interpretation. To address this issue, we created a web-based interface that renders and formats legend entries, presenting the dynamic properties of glyphs, lines, and surfaces, and increasing nuanced object recognition in artist-driven 3D scientific visualizations. Each legend entry includes the variable name, full value range, and artist-chosen artifact.